All right, so now we're going to put this all together. What we've been doing is a little bit basic. We're just dealing with the z-scores, but in reality, this could work for any normally distributed variable. So we have two different types of questions that we're going to encounter. Direct questions, so these are questions where we're going to be asked for a probability, and inverse questions where we're going to be given a probability percent and we want a value out for the distribution. So if you do these by hand, both of these you will move through the z-scores that we saw in the previous sections. If you do them in the calculator, you can basically avoid z-scores by just putting in the appropriate mean and standard deviation. So up to you which one of these you handle. I will do the first one both ways, and then I will just use the calculator shortcuts from there on out. So our first exercise, college women's heights. Assume that college women's heights follow a normal curve. This is going to be our keyword to let us know that we're doing something with a normal distribution. The nice thing about normal is it has to be told to you that it is normal, otherwise you're not doing a normal problem. With a mean of 65, so there's our mu, and a standard deviation of 2.7. All right, find the probability. So immediately I know that we're doing a direct question. This means we're looking for an area under the curve. If I wanted to, I could even use my probability notation, but completely unnecessary. I like the picture more than I like the probability notation. And then a college woman selected at random is shorter than 62. So we're looking for a height to be less than 62. Again, no need to do this notation. Like I said, the thing I would do instead is draw your curve. You had the word normal, so we should be drawing a normal curve. Now we know the mean is 65, so instead of 0, we're going to write 65. And we're interested in, like we said, shorter than 62. So 62 is somewhere below 65, and shorter tells me that we want to shade to the left. So I'm going to do this one by hand, and then I'll do everything else in the calculator from here on out. But if I was to do this one by hand, without the calculator, to use the table, step 1 would be that I don't want to be in X. I want to be in Z land because I need a Z-score if I'm going to use the table. So your step 1 will be to figure out a z-score, which is just x minus mu over sigma. This is on our formula sheet for the test. You don't have to memorize it. So basically, we had a 62. How far from our average of 65 is that? Based on our standard deviations, right? How many bunny hops are we dealing with? So we could do that in our calculator, making sure to do the subtraction before we divide by that 2.7. We get out a z-score of negative 1.11, which makes sense. We're above the standard. We're below the average and more than a bunny hop. A little more than a bunny hop. It's a terrible bunny hop. And then your second step, if you're doing this by hand, because you can see up here it says, you take the x, turn it into a z, take this observation of 62, make it into a z-score, and then we can look up our probability. Here's where you'd go to the table. So we're already on the left side, which is exactly what the table is. We now have a z-score, so all we'd have to do is go negative 1.11. So there we are, 0.1335. .1335. And this looks reasonable given what we shaded in terms of our curve, right? So we can feel pretty good about this. Last piece you should do is sort of check with your drawing. Now, if we want to do this by the calculator, we can just jump straight to normal CDF. The lower bound of what we're interested in is going to be, well, we went off forever to negative infinity, so we'll use negative E99. Our upper bound, well, we're going to go up to that 62. Our mean was 65, and our standard deviation was 2.7. So I can ask the calculator I can plug all this in, negative E99, 62, 65, 2.7, and it's going to give me out 0.1333. So slightly different than what we got here, but that's because this is able to get out that z-score with the repeated 1. So this is more exact than the table where we had to truncate our z-score at that 100th place. So this is a better version of that probability. All right, so I want you guys to try out the next two. Try using the calculator if you have one. If not, you can try through the table and make sure that your values are the same as mine, at least to that last decimal point, especially if you're using the table. All right, so the next two are also asking for probabilities. So we're going to draw our curve, centered at 65. Draw our curve, centered at 65. And the first one says more than 68. So now we're at 68 and above. And then this is going to be a normal CDF because we're looking for this area. Lower bound is going to be that 68 because that's the first part that we're interested in. We can come left to right. Then we shade, and we keep shading forever and ever and ever off to positive infinity, which is our E99. And then our mean and our standard deviation, right? So lower, upper, mean, and standard deviation. So I'm not even going to do this. I know the answer. It's 0.1333 again. And that makes sense because before we were exactly 3 below, and now we're exactly 3 above, and this thing is symmetric. So the last one, find the probability a college woman selected at random is between 60 and 68 inches. So 60 is well below our 65, and 68 is above. So we're looking for this. And this is where normal CDF really shines because we don't have to worry about the E99 and which direction it is. The lower is 60, the upper is 68, our mean is 65, and our standard deviation is 2.7. So this one is a heck of a lot less work with the calculator than the table would have been, because the table we'd calculate 2 different z-scores, and then we'd have to do that weird subtraction thing, look them both up and subtract. So we should get out 0.8347. But yeah, if we were doing this one by hand, if you're not ever going to do it by hand, don't worry about this. But if you're going to do this one by hand, you'd have a z-score for the 60. You'd have a z-score for the 68. You would look them both up, and then you would subtract. Technically, you should have done the 68 minus the 60, whatever you looked up in the table. So we do the lookup first, and then we'd subtract. But you should get something very similar to what we got out.